Very good morning to all of you. Today I want to start Module 1, Session 5, and title of the Module 1 is Subsurface Exploration. Course outcome is given by ability to plan and execute geotechnical site investigation program for different civil engineering projects. Subject title is Applied Geotechnical Engineering. Subject code is 18 CV62 in 6th semester of Civil Engineering Department. Today's session 5 contents are prepared here. So those contents are required to explain in details. So now here these are the contents are these types of samples. In type of samples, disturbed samples, undisturbed samples, and undisturbed samples, representative samples, non-representative samples, and disturbed samples. So today's class is explain in details about samples. So sample means soil samples. Sampler means instruments. To collect the sample by equipment is called sampler. Okay. So here disturbed samples. The property of the soil depend to a large extent on the structural configuration of the soil particles in the natural state. This is especially true in the case of cohesive soils. If a sample during the process of sampling gets disturbed, the sample is designated as a disturbed samples. In the disturbed samples, representative samples explanation is required. In the representative samples contain all the mineral constituents of the soil, but the structure of the soil may be significantly disturbed. The water content may also have changed. They are suitable for identification and for the determination of certain physical properties such as Atterberg limits and grain specific gravity. In case of soil sample brought to the surface from some depths, retain all the constituents present in the soil in its natural state at that particular depth from which it is taken. The sample is designated as a representative samples. Non-representative samples. Okay. In case some constituents of the soil are lost during the process of sampling, or if some constituents of the soil other layers get mixed up with the sample from a particular depth, the sample may be designated as non-representative soil samples. The representative samples of a soil are suitable for classification and chemical tests, but the non-representative samples only give an identification of the major stratifications of the soils. Next, undisturbed samples. What do you mean by undisturbed samples? May be defined as those in which the material has been subjected to minimum disturbance so that the samples are suitable for strength tests and consolidation tests. Tube samples and chunk samples are considered to fall in this category. A sample of soil which retains the natural soil structure after sampling is called an undisturbed sample. This type of sampling is used for more precise tests like the shear strength or consolidation tests. Now I want to explain in details samplers. Earlier I have already told sampler means equipments and sample means soil specimens which we are obtained from earth. Here types of samplers: split spoon sampler, thin walled samplers, piston samplers. So these are the three types of samplers. In piston samplers, hydraulically operated piston sampler and bishop sampler. Now I want to explain in detail split spoon sampler. See, this is the diagram for split spoon samplers. So this is the tube split along these lines, and this is 75 mm width. This is a drive shoe. This is the 20 mm height inclines, 1.6 mm thickness. This is split spoon. This is called 4 vent ports, 10 times diameter minimum. Flat far wings this, and this is sample head of internal diameter 35 mm, external diameter 51.8 mm. This is split spoon sample. A split spoon sampler consists of a thick walled steel tube split lengthwise. It carries a cutting edge called a cutting shoe at the level end and a head at the upper end. The maker of the sampler currently available in the market have an outer diameter ranging from 2 inches to 4.5 inches and the internal diameter ranging from 1.5 inches to 4 inches. The overall length in all cases is 24 inches. The Indian standard recommends a size outer diameter 50.8 mm and inner diameter 35 mm. The sampler is lowered into the bottom of the borehole with the help of drilling rods and is driven into the soil with hammer blows. After penetration to full depth, it is pulled out. Now I am explaining how to collect the soil sample by split spoon sampler. The cutting shoe and the head are removed and the soil is examined usually. Then it can be bottled and sealed for shipment to the laboratory for further examinations. A split spoon sampler is used in the standard penetration test is conducted. All of you remember, this split spoon sampler is used in the SPT test. Properties of cohesive soils are obtained from the undisturbed samples, and for sampling, thin walled tubes, popularly known as Selby tubes, are used. Let us see explanation about thin walled tube samplers. Okay, thin walled sampler as standardized by the ISI 213 to 1986 Code of Practice for thin wall tube sampling of soils is given by the below figures. So this is the length as specified. This is mounting hole 10 mm diameter minimum, and this is thickness as specified, and this is 12 mm thickness minimums. A thin wall tube sampler is a seamless tube with very thin walls. The Indian Standard Institution recommends that the tube shall be 40 mm to 125 mm in outside diameter and should be made of steel, brass or aluminium. The size and wall thickness are as recommended by ISI of these tubes are given below. According to IS code, outside diameter in mm, the 40 mm, 50 mm, 55 mm, 65 mm, 75 mm, 125 mm. Wall thickness in mm is given 12.5 mm, 12.5 mm, 12.5 mm, 17 mm, 17 mm, 31.5 mm. Outside diameter in mm, this is inside diameters. In outside diameter in mm's. Okay, 40, 50, 55, 65, 75, 125. Wall thickness in mm. So I think this is repeated, no problems. Okay. So outside and wall thickness one, this is repeated. Okay, sorry. The length of tube shall be 10 times the diameter for sampling in sandy soils, and it shall be 10 to 15 times the diameter for sampling in clay soils, subject to a maximum of 60 centimeters. The lower end of the tube is sharpened to form a cutting edge. One typical tube is shown in above figures. This is the lower ends. Okay. The tube can be fitted to a head attached to a drilling rod. Static force is applied to push the tube in the bottom of the borehole dug to the required depth. So this is the explanation about how to collect the soil samples. The tube can be fitted to a head attached to a drilling rod. Static force is applied to push the tube in the bottom of the borehole to dug the required length of the soils. Next is explanation about piston samplers. Okay, piston samplers. Sometimes it happens that the soil tends to drop out from the sampler while being withdrawn. In such cases, piston samplers are available in the markets. Dr. Osterberg developed a piston sampler whose principle is explained in below figure, and this is the most advantageous among all the piston samplers. So this is the piston sampler diagrams. This is Osterberg piston samplers. See, this is a drill rod, this is sampler head, this is pressure cylinders, and this is hollow rod, this is fixed pistons. Okay, Osterberg piston samplers. Okay, so this is most important. Piston samplers are used to collect the soil samples for examining the physical properties of the obtained soil samples. Sample disturbance. This is also one more important parameters. Sample disturbance. Some sample disturbance by any one of the sampling techniques, either it is a disturbed sample, undisturbed sample, representative samples or non-representative samples. However, sophisticated they may be usually occurs. So sample disturbance is the most precocious word in collecting the soil samples. As far as the sampling by the use of the tube sampler is connected, the area ratio is an index to the sample disturbance. Area ratio is defined as area ratio ER equal to d square minus di square by di square into 100. Here, so in this equation, AR equal to d square minus di square by di square into 100. This is equation 1, where d means external diameter of the sampling tube in mm. di means internal diameter of the sampling tube, and it represents approximately the ratio between the volume of displaced soil and the volume of the samples. Area ratio is represented approximately the ratio between the volume of displaced soil and the volume of the samples. If this ratio is less than 10%, the disturbance is considered negligible. If this ratio is, that is area ratio is less than 10%, the disturbance is considered negligible. The area ratio of the split spoon sampler is approximately 30%, and hence a sample obtained is a disturbed samples. Sample obtained is a disturbed samples. The ratios for the sampling tubes mentioned in above table 1 are less than 10%, and hence a sample obtained with these tube is an undisturbed samples. So here, how to explain area ratio, recovery ratio, clearance ratio by using these diagrams. See this diagram. So this is from here to here D0, and here to here DC, and this is 20 degree inclined, Di internal diameter. See this sampler here, this is DC, and this is Di, and this is D0, where D0 is outside diameter of sampling tube. Di is nothing but an inside diameter of sampling tube in mm, and DC is nothing but a inside diameter of cutting edge in mm. Is given the relation DC is less than Di is less than D0. Area ratio is given by the equation AR equal to d square minus di square by di square into 100. This is equation number 2. Inside clearance ratio ICR is given by the equations di minus dc by dc into 100. This is equation 3. Outside clearance ratio OR equal to d0 minus dc by dc into 100. This is equation 1. In all these formula we are expressed in terms of percentage. Area ratio for undisturbed samples obtaining is maximum permissible area ratio is 12% for 50 mm diameter samplers, 15% for 75 mm diameter samplers, and 20% for 100 mm diameter samplers. So these are the values are confirmed. Inside clearance ratio for undisturbed samples obtaining should be between 0.5 to 3% for different types of samplers. 0.5 to 3% for different samplers. Low value of clearance ratio is recommended for sampling in sands, while clearance ratio up to 3% may be needed in obtaining good sample recovery in certain clays. Now I want to explain recovery ratio RR. The practical requirement to be satisfied by a sample for accepting it is an undisturbed sample is given by recovery ratio. The overall condition of a soil sample taken in a tube is represented by the total recovery ratio is defined as total recovery ratio equal to length of the sample before withdrawal divided by penetration of sampler below the bottom of the boreholes. When it's given L by H into 100. Gross recovery ratio is given by the definition distance from the top of the sample to the cutting edge divided by penetration of sampler below the bottom of the boreholes, means LS by H. The gross recovery ratio is defined as, and it's considered, should be used in computing the recovery ratio for soil samples. The gross recovery ratio should be used in computing the recovery ratio for soil samples. The net recovery ratio is given by the definition net length of the sample to the penetration of sampler below the bottom of the boreholes, and it's given by the equation Ln by H. So these are the references are made for session 5 with different authors. Thank you one and all. Next class I will be continue.